Hello, my name is Mahar Al-Asfar, and I am a product marketing engineer within the VMware Cloud Foundation division at Broadcom. In this video series, we will demo the VCF private cloud experience, where ACME Corp needs to test and deploy a new customer portal application for their sales team. In part 4 of this video series, we will take a look at how IT operations can monitor the infrastructure and application stacks performance, cost, and capacity. So let's get started. On our VCF private cloud experience slide, we will be focusing on the IT operation demo. So we're going to click into that and we're going to be asked to log in into VCF operations. Here we're logging in as the IT administrator or IT operations persona. The username is Rashmi. I'm going to log in and we're going to land on the home screen, which is going to gives us an overview of everything being monitored by VCF operations. So all our VMware clouds, we can see our monitoring accounts where we have one VCF account that contains 2 VCF domain, that contains 2 vCenters, and then the inventory for number of data centers, compute resource clusters, host systems, virtual machines, etc. For the purpose of this demo, we're going to focus on the infrastructure operations, dashboard, and reports, and we have a few dashboards to go through. The first one is going to give us a Kubernetes inventory of the overall context of the representation of Kubernetes, starting with the supervisor cluster. Highlighting the supervisor is going to give us key metrics on that object in terms of here, as we can see, number of containers, number of stateful sets, number of pods, nodes, namespaces, deployments, and daemon sets, etc. If we scroll down the dashboard, we see the supervisor object again here. It consists of 4 nodes, and it's currently running 22 namespaces. Clicking on the supervisor is going to interact with the remaining widgets. So we see the VKS clusters running on this cluster. So we have 3 Kubernetes clusters running on our supervisor. And within that supervisor, we see the namespaces there's 22 namespaces. And then we see a breakdown of the workloads running on those namespaces, the pods, and the containers down to the container level. If we focus now on the VKS cluster itself, so we click on the Kubernetes VKS cluster dashboard. Now we see the VKS cluster themselves. These are the VKS clusters that are provisioned as infrastructure on top of the supervisor. And we see things like their peak CPU throttling, the usage in terms of how many CPUs, and their top 95 percentile of workload CPU throttling. This is going to show us that what was the worst case scenario. And we can see here that the worst case scenario was 1.66%, which is really not a problem. And also we see relevant properties for this cluster that we're highlighting, which is the portal brought cluster 01, in terms of relevant properties like number of containers running on it, number of daemon sets, number of deployments, namespaces, nodes, and pods, etc. Highlighting the cluster also at the bottom shows us the nodes within the cluster. This is the production cluster that we've provisioned in the last video through the catalog item. So we can see that there are 3 control VMs and 2 worker nodes. So if we highlight one of these nodes, where it's going to populate the rest of the widgets in the dashboard, like the etcd backend database that the Kubernetes cluster is using. We see, there's a leader has been elected. There was 3 proposals for the election process. And we also see the top 95 percentile of the workload CPU throttling and the workload out of memory, 95 also percent of workload out of memory sort of a metric. If we scroll down the dashboard, we see additional information around the namespaces running on this node. And if we highlight any of those namespaces, it can cascade down to the pods and the container within those namespaces. Now, if we want to focus on the vSphere supervisor itself, we have a dashboard that's called vSphere Supervisor that's going to show us the supervisor and its basically related information and properties. So again, we see that there is a peak CPU throttling of 25%. Obviously, that's not good. the top 95 percentile of the workload CPU throttling being limited to or slowed down at a point of 25%. And then we see the relevant properties here again: number of namespaces, number of daemon sets, and the objects running on the supervisor level. We also see the nodes. These nodes there are 3 VM control plane for the supervisor. And then if we select one of them, we see the etcd operations. We can see that a leader has been elected. There has been 3 proposals, and these are like internal backend operations for the etcd object database. And the top 95 percentile of both the workload CPU throttling and the workload out of memory, but now on the node level. Scrolling down, we can see the namespaces. And again, if we highlight one of those namespaces, we see that we see the pods running within this kube system namespace that I just clicked on. And we see the containers running within those pods as well. And the relevant metrics like CPU throttling, memory throttling, or number of times that the pod restarted. The critical business application is going to give us an average of all the business application performance over time. We see the application tiers, and we also can click onto to go to the, for example, to the pod sales customer portal. That takes us to the custom application or business critical application that we've created within VCF operations. On the summary page, we can see the business application topology. So it shows us that the sales customer portal application has 3 tiers, one being the database that is contained or includes the virtual machine. It's running on a virtual machine. Then we have the web app tier, and the that basically runs in a namespace, which is customer portal on the VKS cluster, and then the VKS cluster nodes. So we see 5 nodes here for the VKS cluster for this production application. If we click on the infrastructure side of the topology, we see the cluster it's running on, we see the host it's running on, and then we see all the cluster nodes as virtual machines running on their respective ESXi host. Clicking the metrics on the application allows us to interact with the application topology from a business perspective. So I can expand the database tier, I can see the virtual machine and expand that, and I'll then see the running database on it. Selecting the database allows us to access the database metrics. So here, for example, I'm going to go and check how many connection attempts per second that happen on this database, and we can see that over time. And then if I expand the web app tier that we saw in the business topology, we see the customer portal namespace where the backend and the front end app tier of the application is running within. And then if I click on the customer portal, I can get metrics on that level for things like CPU usage, which is per core, and the memory usage, which is gigabyte over time. And we can see this side by side, comparing the connection on the database versus the CPU and memory usage on the application deployment side within the VKS cluster. Now moving to cost. If we go under capacity and cost, we see cost of ownership by capacity, by cost drivers, by VCF domains, and that's going to give us what our cost of ownership is. But more importantly, if we click chargeback, and this is going to be in the context of VCFA, it's going to give us a summary of how many organizations we're managing, how many region quotas has been assigned, how many VKS cluster has been provisioned by these organizations, total number of VMs, and the ongoing price versus the cost of ownership. So this is basically how much you're selling it for versus how much is costing you as IT operations. And we can see the organization detail at the bottom, where we see number of region quotas, number of VM, and a breakdown of the number of running VMs, again, versus the cost, the total cost, which is the cost of ownership to IT, versus the ongoing price in terms of how much they're charging these organizations. If we want more detail and we can bring it down to the organization level, we see that this is the ACME sales organization that we kind of created in this video series. We see its total cost of ownership month to date, and we see the price. Actually, we're making some profit here. And this profit is definitely not coming from CPU because we have a loss here. The CPU cost is costing us 60 while we're selling it for 10. So versus the memory where it's costing us 114 and being sold for 830, for example. And then the organization cost versus price trend over time. And at the bottom, we see a breakdown of the region quotas. Of course, an organization can have multiple region quotas. This happens to be the US West region, but if you had like US East region, you'll see a comparison of these region quotas. And then these numbers will bubble up and be aggregated on the org level. And if we're going to go further and break it down by project, if we select our ACME sales organization, we see the customer portal project that we created previously, and we see the total cost and price for that or on a project level, and also the project cost versus price trend over time. IT operations can also generate bills. So we can generate a bill based on those metrics. So for ACME sales, I'm going to just simply select from April 1st to April 16th. I'm going to select the start date of April 1st to April 16th, which means 2 weeks. I'm going to generate a bill for ACME sales organization. And I'm going to do this by just dragging and dropping the region quota. I could flip the toggle to organization and do it at that level, but I only want to do it on the region quota level. So once I drag the quota to generate the bill and hit create, that's going to generate a bill for us. And if we click on this bill, we can see the billing date, start and end, and the total price for that bill. And if we click into this bill, we can see information on terms of the total price for the ACME sales organization, the breakdown of this $84 and those 2 weeks by storage policies, memories, and virtual CPU and VM creation. And if we scroll down a little bit, we can further do a chargeback resource detail based on, the namespace level. So this $84 is actually coming from two different namespaces, one being the development where it was 31, and then the other one was being production, which was 42. The same bill is once it's generated on the VCF operations side, it's easily seen by the organization admin. So if the admin goes to the administrator and goes to bills, we see that same generated bill showing up as an expense for their resource usage across organization. And if the org admin clicks for details, he sees the same total price that we saw in VCF operations. We see the breakdown of this $84 across storage policies, memories, vCPUs, and VM creation. And if we scroll down, we see that we can break it down into resource details in terms of where that 84 coming from. So again, we see that 31 is coming from the development namespace versus 42 coming from the production namespace. Using VMware Cloud Foundation, ACME Corp was able to build a private cloud while abstracting the underlying backend services and monitor the performance, cost, and capacity of that infrastructure. This provides a seamless and uniform way to consume and deploy infrastructure and application across the entire VCF Cloud Foundation fleet, ensuring efficiency and ease of use. That wraps up this video and the series. We hope this walkthrough helped clarify the VCF private cloud experience and gave you the necessary tools to move forward. Until next time, thank you for watching.